Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokpo Jr., your math tutor and an instructor of mathematics at the University of Liberia. In today's lesson, we'll want to look at the chain rule. So in previous lessons, we prove the chain rule, or we derive the formula for the chain rule. So in this lesson, we want to solve some problems involving how we can apply the chain rule on finding the derivatives of a function. So I want to look at the first three problems. First problem says y equals to the root of 3x minus 5. Now, the essence of using the chain rule is to reduce a complex problem into a form that you can easily differentiate. Now, most often, you apply the chain rule whenever you have an expression raised to a high power. For instance, if we have x squared plus 1 raised to the 30th power, for instance, right? We cannot just be expanding this thing x squared plus 1 times x squared plus 1 times x squared plus 1 to multiply all of them like we would do if we have x squared plus 1 raised to the second power. For these ones, these are easy. Even if it was the third power, if it was the fourth power, it will be easier for us. But when you have like maybe 300, you have like 100, 1000, then you can apply the chain rule. Sometimes we also avoid the chain rule, but we are still indirectly applying the chain rule and just use the power rule. Drop the power, rewrite the expression, and differentiate inside. So we are applying the chain rule, but we are going direct. We are not doing it stage by stage. So we will first start with solving problems using the chain rule stage by stage. Then when we move ahead, we can just directly find the integral, the derivative of problems directly instead of wasting our time to use the first step, the second step, and everything. Like for this problem. This problem is in the form of x raised to the power 4. Like the way we would say, drop the power 4, rewrite the expression, and subtract 1 from the power 3. We could do the same right here. But when we reach there, we will cross that bridge. So let's go now. Let's go. The first problem says y equals to the square root of 3x minus 5. So square root gave us, some difficulties most times when we are dealing with square root. So we want to get rid of this square root somehow. We don't want to have a problem wherein we have a long expression under the square root. So we say, since we want to avoid finding the derivative of a long expression under the square root, we can substitute what is under the square root with a single variable. So remember, this square root can be rewritten as 3x minus 5 raised to the power 1 over 2. Half means square root, right? So we can say now you saw in this formula we said u is equals to g of x. So if you have a function and then another function is inside, like you have this is a radical function. Then within this radical function, you have a linear function. So we can say let u equals to this linear function that is within the radical. Then what we do, we only need the derivative of u with respect to x and the derivative of y with respect to u. So how do we get the first one, derivative of u with respect to x? If you substitute what is within here with u, you must differentiate this u. So it becomes the derivative of u with respect to the variable in the function, which is x, derivative of x. What's the derivative of 3x? It's just 3, right? We've gotten the first one. This one, we're done. We now need to find this. How do we get that? We know that y equals to 3x minus 5 raised to the power half. But we substituted this 3x minus 5 with u. So it becomes u raised to the power 1 over 2. So you see that this is easy for us to deal with. A single variable raised to the power half, which is apply the power rule. So we say y prime or dy by du, because the variable now is no longer x. The variable in the problem is u. So dy with respect to the variable, which is u, so dy by du equals, we use the power rule. This 1 over 2, we bring it down, 1 over 2. We rewrite this u and subtract 1 from this 1 over 2. So for short, you can just say 2 times 1. So it's 1 minus 2 times 1 is 2, all over 2. So 1 minus 2 gives us minus 1 over 2. So this now becomes minus 1 over 2. So this is our u. If we can rewrite this, this is our dy by du. If we rewrite this, we will have 1 all over, because the power is negative, we reciprocate 1 all over 2u raised to the power 1 over 2. So we can write our final answer now by just multiplying the two of them, this and this. So we have dy by du by dx is just equals to du by dx, the first one, which is 3, times dy by du, which is 1 all over 2 u raised to the power 1 over 2. Well, what was u from the beginning? From the beginning, u was equal to 3x minus 5. Always bring back the u, because your original variable was x and not u, right? So it's equal to 3 all over 2. U now is 3x minus 5 raised to the power 1 over 2. So this is our answer. We are not too concerned about simplifying the answer further, but this is our answer. If you like, you can rationalize this expression so that you get rid of this square root from the denominator, but it won't do anything, it won't change the problem in your major form. You will still have all of these things still remaining. If it could reduce the problem further, then we could rationalize this 3x minus 5. So let's do the next one. Let's do the next one quickly. So the next problem says f of x is equals 1 all over x minus 1. So now, for this, it's just easy, right? It's just very, very easy. It's very, very easy. So assume that you had this entire thing raised to the first power, right? You had this entire thing raised to the first power. Or you want to say, okay, since you have two terms down here, you want to change these two terms to just a single term. It's nothing basically is going to change, right? So we can say let u equals to x minus 1, if you like. So now we have du by dx is just equal to, the derivative of x is just 1. We've gotten du by dx. Go back to the problem. Now, this 1 over x minus 1. X minus 1 was just u, right? Well, we can rewrite this thing as y. We know that the function f can also be rewritten as y, just, so that we don't get ourselves confused with our formula. So y now will be 1 all over u. So you will just have a single variable now within the denominator. So what do? You find the y by du, because the variable here is u. We use the quotient rule that we applied previously. We hold this u and differentiate 1, we get 0. Minus, we hold 1 and differentiate u, we get 1. All over, we square u. So this cancel. So we have dy by du is just equals to minus 1 over u squared. So now we can find our final answer, which is dy by dx, and it is du by dx, which is this one, 1 times dy by du, which is minus 1 over u squared. So what would this be equal to? So this is just minus 1 all over. Now u now is x minus 1 raised to the second power. So this is it. It's very, very simple, right? It's just easy, you know. So let's do the last one. Then we move to other higher problems, you know. So the next problem says g of x is equals to x cubed minus 2x squared plus 7x minus 3 raised to the 4th power. So you see that if you multiply this 4 times, it's going to be very long. So what you can do, you apply your Chen rule. So what is inside? What is inside? The innermost portion, you take it out and substitute it with some variable u. So we say let this portion be equal to u. So it's x cubed minus 2x squared plus 7x minus 3. Then what do? You find the u by dx. So the u by dx is just equal to, what's the derivative of x cubed? We bring this power down, 3. Rewrite x and subtract 1 from this 3, it gives us 2. 2 times 2 is 4. Subtract 1 from 2, it gives us 1. 1 times 7 is 7. Subtract 1 from 7 is 0. X to the 0 power is just 1. Derivative of a constant goes to 0. So we've gotten our du by dx. The next thing we need to get is dy by du. So we consider this function to be 1. And then this entire expression now is being substituted with u, right? Or u now is raised to the 4th power. So now we find our dy by du. So this power drops 4. U, we subtract 1 from the power is 3. Now we just find our dy by dx. Dy by dx. So it is du by dx, the first one, which is this. 3x squared minus 4x plus 7 times dy by du, which is 4u cubed. 4u cubed. But what is u? U was x. Let's rewrite it first. 4u cubed. So dy now by dx is just equal. Now this 4, I bring it outside like this. So I write it 3x squared minus 4x plus 7 times this u raised to the 3rd power. U is 3x squared minus 4x plus 7 raised to the 3rd power. So this is it. But let's avoid this long diplomatic way of solving this simple problem, right? Let's avoid this kind of long. This is very long. If you have an exam to complete in a short period of time, and you have so many problems to solve, doing this is very long. So this is what you have to do. Whenever you have an expression in this form, it must be written in the form of an expression raised to a particular power. Then you apply the power rule, but now we call it the extended power rule. Why is it extended power rule? Because we are not only differentiating, we are not only dealing with this power, we are also dealing with the powers in. So we call it the extended power rule. That is when you bring this thing down, you must also differentiate the individual terms in here. So that's the other form of the chain rule. So let's look there. So g prime of x, this 4, we grab this 4, right? 4. Then what do? We rewrite this entire expression without differentiating. So it's x cubed minus 2x squared plus 7x minus 3. We subtract 1 from this power, it gives us 3. Then we go inside, we differentiate inside now. So the derivative of x cubed, do them one by one. X cubed, this is 3x squared minus 2 times 2, 4x plus 7x is just 7. So this was the same thing we got, right? So we can bring this one first because the power here is less. So it's 3x squared minus 4x plus 7 times x cubed minus 2x squared plus 7x minus 3 raised to the third power. There is g prime of x. So instead of saying let u be this, and then you find the u by the x, and after that you find the y by the u, then before finding the y by the x, it's just a long way of arriving at a single point. You know, you want to arrive at this particular point, and instead of you just leaving from right here to come here, you went like this, you went like this, and then you arrive at this point. So this is it. Thanks ever so much for watching. Please don't forget to subscribe, like, hit the notification button so that you get alerts to any upload. So in our next video, we want to solve more problems, more challenging problems on the chain rule. Thank you. See you next class.